Hi, welcome back to Python programming. In this series of from beginner to programmer discussions, I like to impart my knowledge to allow you to see through the easier aspects of programming. It's not that difficult to get started. All right, so if you are having no knowledge, absolutely nothing at all about programming, this is the place that I hope I can level you up and share some fun and joy that I have along the way. Now let's get started with today's topic. And what I want you to be clear about right from the beginning is how Python looks at the world. Um, it is not in a haphazard way. It is also not a very disorganized manner. It's very regimental. It's very robotic, and hence, of course, we see all the robotic movements. But how does it get structured into smaller components? How does Python think? And this is what we want to talk about. How can we drive Python in the way that is natural to itself? How does it follow instructions? So all these are discussed under the brand name called logic flow. All right. And the idea is that Python follows certain logic, and that is, of course, uh, where we start to write the program. The program will deliver the logic to Python. Python will execute it. Now, the word execute, uh, it's not the usual English meaning. It just means that Python runs the code, right, and follows the instructions to the last bit, literally, right? Now, there are four main kinds of execution instructions uh, involved in Python, and how Python uh, flows its program, right? So these are the four types. Sequential flow, sort of like going from 1 to 2 to 3 to 4, that's sequential. Then we have conditional flow. That means if something happens, right, if certain um, variable has certain values, if the money in the ATM in my bank account is less than certain amount, then signal a certain message to the account owner. So that's really nice, right? Loops will be where you have going backwards, because sequence always goes forward. And conditional statements in the second part branches uh, the flow either into the left side or the right side. And loops for once, and that's the only situation when we can redirect Python to go backwards in sequence, right? To go backwards in sequence. And finally, jump, it's a little bit like your HTML web page, where if you click the link, it can literally jump to anywhere in the world, right? Because the link can point to any web page. I can't imagine talking about this to any person who is not computer science trained 5 years, 10 years ago. But right now, it is like everybody has this concept. So I like you to also imagine that, learning Python is really, really possible that everyone thinks like that. So long as you know where to start, what is the gist of it, rather than having to face the cliff of paging through thousands of pages of manuals and textbooks and all that in order to know a little bit. So here, the gist essence, right? So Python will do sequence. Think of sequence as timeline. Okay, Python will just tick tock, run through, and every uh, bit of the timeline has certain instructions that Python will follow and do, right? When we say execute the code. So we write the code. Python always, without any instruction, it will always start off by sequentially executing it. Now, think of sequential execution as timeline, right? Because that gives us timeline, and timeline, because it automatically moves in time, this gives us uh, flow. Flow means there is energy, and energy means there is life. Okay, so this is not some sort of a metaphysics or pseudo philosophical statement, but actually, when robot moves and becomes really lifelike, that's more because it's always the whatever language is involved, and Python can be one of them, always executes in sequence. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the engine that makes it move, of course, is the CPU. So when we put in the code, it's always line by line execution. We'll see that in a while in more detail. What we have for condition, I like you to think of it as a Y junction, right? As a Y junction along the road. As we move towards a condition, then Python will stop and check. There will always be a check. If certain status is true or false. It can only do these two. Now, of course, it can be if it is equal to 1 or not, right? And the not part, we can also put in another condition. If it is equal to 2 or not. And because of that ability to nest, that means put one condition inside another condition, inside another condition, we are able to then sort of pseudo implement the concept of many different conditions, then do that, right? So, but literally, Python just looks at the condition and says if this is true or not, or false. So it's a Y junction, but Y junction, because of the built-in ability for Python to examine the condition, then decide whether to go left or right, it implies that there is certain smartness that it can decide. I literally use the word decide where it's more applicable to human. So it literally decides whether it is true or false, and then do accordingly. Of course, according to our instruction, pre-programmed instruction. But because we can pre-program it in a way that looks smart, it is giving rise to some sort of intelligence. Apparently, although there is no true intelligence, it cannot think for itself. It cannot try to say save myself, even though the code asks me to destroy myself. It cannot do those thinking. But you can literally say that, well, we are now making it pretend like it's lifelike, and conditional statements, as we'll see in a while, gives rise to artificial intelligence sort of behavior. Okay, and of course, loops are of what brings Python backwards in time, because it brings us backwards in the sequence, and because sequence represents time, because it's always moving, and so there's a sense of before and after. Before I was executing this, after I'm doing the other part of the code, right? So loop for it's so important because it is the only way for Python to go back in time. Yeah, and because of that, go back in time, go back to the starting of the sequence, or somewhere in the sequence in the past. It will then continue again, right? It will continue the sequence again, and then comes to the juncture. It will loop back again to the same old starting point, and then it will run again. So it becomes a loop in that sense. And of course, we need to stick in a condition to make sure that you keep on doing the same thing until you have reached certain condition, then you exit the loop, right? So we need to stick in a condition there. Think of it as keep on working, keep on studying hard, keep on working, keep on studying hard, right? So repeat through time, and until I have accumulated a certain amount of money, then I can relax a little bit. Then I exit the hard working loop. That is part of what we do in real life too. So go back in time. What does it signify in the real world? Go back in time means you repeat doing same thing many times. That is the implication when we so-called go back in time, where our time is actually sequence, right? Because we just built that analogy. So looping back again and again, doing the same thing again and again, that means power, because that same thing, the code, the sequence code that we write is one time. But in real time, when computer runs it, when Python runs it, it's actually doing it many times. And when I say many, it is electronic kind of magnitude. That means we can let it run 100,000 times, no problem. For example, spreadsheet, right? Excel spreadsheet. We have one row. One row contains one customer information. But I like to process this same processing. For example, add up customer spending from beginning of month to end of month for 30 columns, right? So at one row, one customer, 30 columns, daily spending. I like to do this for my 1 million customer. So if all we have in Python is sequence and condition, There's no way to do it effectively unless we repeat the sequence and copy and paste 1,000 times. But we have to go back and say, because we copy and paste and do for customer 11111, we have to change it to 2, 3, 4, 5, 6. What a chore, right? That is impossible. So because of loop, we keep repeating the same processing for that customer, but on different customers. That allows us to gain productivity. So that's the real life productivity. That's the real life contribution. So we have life, we have artificial intelligence and smartness, and we have productivity because we write once and do millions of times, and that's as costly in our time of programming as doing it one time, right? So there are cases where we want it to do only one time. There are cases where we want it to write one time and do many, many times. So all these logic blocks allow us to build rapidly and in a very scalable way, very powerful and very meaningful Python code blocks, right? And lastly, it is jump. Jump represents moving or forcefully moving Python from its current sequential execution. Maybe it's part of the sequence. Maybe it's part of deciding the condition. I branch to the left and then it's a sequence again. Branch to the right, it's a sequence again. Or I'm in the middle of processing a loop and that part of the sequence is being looped over 1 million times. Somewhere along that sequence, we hyper jump out. Okay, we jump to like somewhere else. In particular, it doesn't have to be backwards because that's already done by loop. In particular, it can be number one, jump forward ahead of the sequence or jump to somewhere else into no man's land where Python manages all this memory space, jumps to somewhere where we say we like to run that part of the code, and that's called function call. Right? So we'll talk about more about that, but a jump represents a sort of a hyperlink jump to another part of code. And example, forward jump. Right? So backward jump is already done by loop. It can also be part of a jump, but loop is special in the sense that it actually repeats, right? But jump can be a one-off thing. Jump to there, run the code, then come back, right, to another part of code, and then come back. Oh no, sorry. And then optionally come back. All right. So this part is all detailed by the rest of the discussion. So we'll keep it there, right? So it is basically interesting part of it is it is basically a forward jump or jumping to somewhere else and then come back. So all these allow us to build code and to repeatedly use code. For example, when I already made the code for processing a customer, back to my example, I can always jump to that part of the code, process that customer, come back and repeat the next processing. So this is the idea that we have in mind. Now, I hope you get this idea, this simple idea that Python, for all its apparent complexity, is actually very simple, easy, modular, and that's it. We have the 4 building blocks here. That's it, right? There's no other ways to sort of think about Python in terms of logic flow. You can always categorize them as these 4: sequence, condition, looping, and jump. And you see that they all represent some sort of real life meaning, right? Life, smartness, productivity, and of course, ability to jump across codes whenever we don't need them or we want to reuse them, or so that helps a lot in organizing our code.